My name's Yoshio Hasegawa, and my presentation is on wearable devices, a dynamic technology. So a little bit about myself before we begin. Like Jan said, I was born and raised in Seattle, Washington, and I love nature and I love outdoor activities. So this includes running, cycling, skiing, hiking, mountaineering, climbing, and so on. I think you get the idea. I'm also passionate about software engineering. And the reason why I'm talking about wearable devices today is because I see it as sort of an intersection between my two passions. You see, every time I go out and go on a run or go skiing or go climbing, I always have my Garmin smartwatch on and it's constantly tracking my activities. And when I'm done with my activity and I go home, I like to see my GPS track, kind of do some analysis on my health metrics and just play around with it and have some fun. So that's why I'm talking about wearable devices today. I hope you enjoy the presentation. These are the topics I'll be covering. So I'll first go over the background and history of wearable devices, and then dive into the current wearable devices market today. Then I'll focus in on the smartwatch specifically, talk about capabilities, features, and then I'll do a short demo using the Garmin Connect IQ software development kit. Should be fun. And then I'll close with the future of wearable devices. So moving right along, I first want to give a definition as to what a wearable device is. This is a really great quote from a paper published in Science Direct, but unfortunately it's a lot of words and I just want to keep things pretty simple today for the sake of all of you. And let's extract out 4 key points of what makes up a wearable device. And it boils down to the fact that it's a small electronic device. It has wireless communication, it's worn on the body, and it has monitoring and scanning features. These are the 4 key points of what makes up a wearable device. So now that we know what a wearable device is, let's talk about the history and potentially try and pinpoint exactly when the first wearable device was actually invented. And this can be a debated topic sometimes because of the evolving definition of smartness or technology. You see, as smartness or technology advances and evolves, what qualifies as a wearable device also changes. And so that's why sometimes there's debated conversations about when the first wearable device actually occurred, but I'll make my attempt here for you today. And that brings us to potentially the first wearable device all the way back to the 13th century. This is Roger Bacon's spectacles, invented in the 13th century. It was essentially glasses you put on your head. And it was a form of technology used to improve vision. So considering it's something you wear and it's a technology used to improve vision, you could call Roger Bacon the pioneer of smart glasses. So this is great, we might have found it. But some of you might be saying, well, based on the previous definition that you just provided, it's not an electronic device. And so I'll take that into consideration and let's just move right along. Sorry, Roger Bacon. But this brings us to the first electronic wearable device, and this is Dr. Julius Neubronner's pigeon camera. You heard me right, it's a pigeon camera. Patented in 1907, a 75-gram camera used to take aerial photographs worn by a pigeon. And this photo on the left actually became quite popular because you can see the wing tips of the pigeon carrying the camera. And this is a picture of the Schloss Hotel in Kronberg, Germany. And I guess this makes Mr. Neubronner, Dr. Neubronner, the pioneer of the GoPro, or maybe the drone. I don't know. I'll let you be the judge of that. And maybe this is it. But some of you now might be saying, well, this device was worn by a pigeon. Does it really count? Oh, well, you might be hurting the pigeon's feelings, but I'll take that into consideration also. And let's move forward in our history timeline to the first successful human electronic wearable device, and this is Hewlett-Packard's HP-1, launched in 1977. You see a picture of it here. It also came in gold. It sold for around $650 to $700, depending on the color or the type that you got, and it's quite a collectible. It actually, I guess, sells for around $4,000 today, and for the time when it was launched, $650 is quite expensive. But this was the first smartwatch. It had a stopwatch, an alarm, a timer, told you the date and of course the time. It was pretty cool back then. And so we've come a long way. We've started in the 13th century. We've seen some devices worn by pigeons, and we've seen some successful devices. So now that we know a little bit about the history, I'd like to jump into the current market and kind of see what it looks like. So this graph is A growth forecast, a market growth forecast, originally published in 2016. Keep that in mind. And it was published by ID Tech X Research. They estimated that there'd be a 9% annual growth rate from 2016 through 2018, and then that would jump up to a 23% annual growth rate through 2023. From there, a 10% annual growth rate through 2026, which would bring the total market size over $150 billion. And you can see in 2021, you're kind of right in the middle of this acceleration, which is really timely and really exciting for all of us. And for me, I guess I'm really interested in wearable devices, and it seems like we're all in the middle of this acceleration phase. A more recent article, actually published in Markets and Markets, stated that the wearable technology market was valued at $116 billion this year, and it's anticipated to reach $265 billion by 2026, growing at a compound annual growth rate of 18% from this year through 2026. This is quite a larger estimate than the previous article and the previous graph that I just showed. So it could be the fact that the wearable devices market is growing faster and larger than we had initially expected. This article also stated that Asia Pacific, APAC, would take the largest share of the wearable devices market in 2026, which is also quite interesting. So now that we know a little bit about the background, the history, let's talk about the smartwatch, one of the most successful wearable devices, just based on sheer number of units sold and revenue brought in. And it's my favorite wearable device because I take it with me literally everywhere. So cool, so the smartwatch, it has tons of capabilities. Just for the sake of time, I might breeze through these fairly quickly, but they do have health tracking features, heart rate monitor, pulse oximeter, etc. They have activity tracking, so you can track all sorts of different activities. There's safety features. So I actually use the incident detection feature when I'm out on bike rides. And what this essentially is when you're tracking an activity and you crash or fall, hope you don't, but if you do, your watch can actually detect that incident or estimate whether you might have fallen or not based on a difference in acceleration or early extreme deceleration. And it can send a message, an SOS signal, to your emergency contacts with your GPS location included, which is pretty handy if you're out in the mountains and by yourself, which you shouldn't be, but sometimes it happens. Also navigation features, which are also really important when you're in the mountains and you're by yourself. You shouldn't be by yourself in the mountains, but sometimes it happens. Bluetooth, this is how your smartwatch communicates with other pieces of software. Very key piece of technology included in most, probably all, actually pretty much all smartwatches. So tons of capabilities, tons of features. I just want to focus in on two key pieces of technology, and that's Bluetooth and GNSS. So GNSS is Global Navigation Satellite Systems. And so let's start first with Bluetooth, and let's dive a little bit deeper into these two key pieces of technology. Bluetooth, and how does it communicate with other pieces of software? Well, your smartwatch has a Bluetooth transceiver, and this transceiver uses radio waves to transmit data, and the frequencies it works on are from 2.4 to 2.48 gigahertz. And Bluetooth actually works with very little interference. Bluetooth transceivers can connect to 8 devices at once, switch across 79 different frequencies within the given range, and can actually switch 1,600 times per second, which is quite amazing. And so say you're at your desk, like this Viking here that you see in this photo, and you have a Bluetooth mouse, Bluetooth keyboard, Bluetooth headphones, maybe a Bluetooth sword. These devices have the potential to switch frequencies 1,600 times per second. And this is how they pretty much constantly are staying on different frequencies and not interfering with one another, which is very key and very handy when, say, you're on a Zoom call and your Bluetooth mouse is not interfering with your headphones and messing up your presentation. Moving right along, global navigation satellite systems. And how does your smartwatch utilize this? What is it? And why is it even useful? Well, like Bluetooth, GNSS uses radio waves to transmit data, and it works on frequencies from 1.2 to 1.5 gigahertz. And your smartwatch uses this to get location data. You've probably heard of GPS, and your smartwatch is using something called triangulation to pinpoint where it is on the planet. So imagine you're somewhere on the planet, hopefully not in space, and you have your smartwatch on and you're tracking your activity. What's happening is, say there's one satellite your smartwatch is receiving information from the satellite, and information including the time at which that signal was sent. And then your smartwatch determines the time at which the signal was received. And it takes the difference in time and calculates distance. So with one satellite, it knows that it's somewhere along this yellow circle that's surrounding the satellite. More specifically, it's a spherical plane. So it's somewhere, it knows that it's somewhere in this spherical plane. And you introduce more satellites. So say you have a second, now it knows it's somewhere in the intersection, but it needs a little bit more than that. So you introduce a third, and actually at a minimum, your smartwatch uses 4 satellites to pinpoint location with any form of accuracy. Minimum 4 is where you're going to get any sort of useful information. And so there's a lot of different GNSS systems. Feel free to come back to this slide. I'm just going to gloss through it quickly. But GNSS systems differ across a few different key features. These are altitude at which the satellites are traveling, the orbits. Some move geosynchronously with the planet, meaning relative to the Earth, they're not moving. So they're rotating or orbiting at the same rate the Earth is spinning. The number of planes, the period of revolution, number of satellites in the system, and then the accuracy. This is a civilian accuracy. There's also a government or military accuracy that's down to centimeters, which is quite crazy, but really cool. So these are some of the key features, characteristics, technologies in your smartwatch. Let's dive into a demo. So what I'm going to do is talk a little bit about Garmin's Connect IQ software development kit, and then do a demo. So this SDK uses a language called Monkey C, which is a proprietary programming language developed by Garmin. It was derived from actually a lot of different other languages. Some of them you probably know if you're into programming: Java, JavaScript, Python, Lua, Ruby, and actually a few more than that, which is pretty interesting. They all made an influence or had an impact on the development of Monkey C. So that's about the language, and just a little bit about how to get started. What you would do is just go to this website here, developer.garmin.com/connectiq/overview, and there's a getting started page, and you simply install the SDK manager, install Eclipse, which is an integrated development environment, and then you'd get the Connect IQ plugin for Eclipse, and then you'd simply start your project from there. So it's pretty straightforward if you go to the website, so I won't bore you with the steps of getting set up, but I actually have everything set up here. This is my Eclipse IDE. You can see I have Connect IQ installed already. And like I said, we're just going to start a project here. So you would do Connect IQ project to start a new project, give it a name. So let's just call it Tech Talk Project because that's very fitting. And Garmin gives you a few different project types. A data field, there's really fun things you can do with this. You should look up the number of beers earned. I think people have made a field for that, which is cool. A full-on watch app, a watch face, and a widget. For the sake of the demo today, I'll do a watch face. You can keep everything else the same. Keep templates simple, and then you can select your supported devices. Considering I have a Forerunner 945, let's go ahead, select that, and select English as my supported language. And required permissions can be fine as it is, and click finish. This is going to spin up a project folder and provide you with some code and a few different files. We'll talk about 2 files today. That should be enough to get you started. But before we dive into that, you need to configure a specific run for Eclipse. And what this means is Eclipse needs to know what you're building, what type of application it is, and how to run it. So since we're using Connect IQ and we're building a watch face with that, let's select a new configuration for Connect IQ. Your project will be auto-selected, and so should your device. You just need to give it a name. Something informative helps. So Forerunner 945 API 3 can tell me what it is and help me in the future. So we can click apply. And then we can actually run this application as it is, as Garmin gives it to us. And this should spin up a simulator. And should see the 945 watch. There it is. And it gives us the time. Awesome. So it looks like everything is working great. Let's go ahead and close that. Okay, the 2 files I want to talk about today, which should be enough to get you started. The first one is under the resources folder, and under the layouts folder, it's this layout XML file. What an XML file is essentially a file that houses data. And you can see that there's an element here called, with an ID called time label. And this is the time that we saw on the watch face. It's located in the center, has some font and justification information as well as color. The color is blue, so that's enough information for me to assume that's the time label we saw. So that's great. I'll come back to this in a little bit when we start customizing our watch face. So if we go back to this view file, it's located under your source folder, and it's this Tech Talk project or project name view.mc file, monkey C file, and there's a few different methods here or functions. I'm only going to actually touch on one just for the sake of time, and it's this on update function. And this on update function actually runs every second, so it's re-rendering your watch face every second. What's happening here is from the system class, we're getting the clock time, initializing it, formatting that clock time variable into a string, and then we're grabbing that time label element, and we're simply setting the text to the time string that we've initialized up above on line 27. And I just want to demonstrate that this is actually running every second. So I'm just going to do a simple print line. Let's not forget that. And let's say on update called. Everything looks good. And I just want to show you, I'll go ahead and run this, that this on update function is actually being called every second. So if I click run, as I just did, and run the simulator, you can see on update is printing every second. So let's utilize that. I'll keep that in mind, close the simulator, get rid of this print line because we don't need it anymore. Go back to the layout file and let's add some elements. Let's customize our watch face. Super exciting. There's a lot of different elements that you can create. And you can look at the documentation for what types of elements there are. For today, what I want to do simply is create a text area. It's exactly what it sounds like. It's an area that lets you put some text to show on your watch face. It needs some properties. So it also needs an ID so we can capture it. It needs an X and Y, so a location. Let's put X in the center, and then Y, we can actually say 60%, and that's 60% from the top. So that should put it somewhere just below our time label. And then we also need font justification and color. I'm just going to go ahead and copy paste because that's what all programmers do. Boom, boom. Sweet. Actually, I want to make this yellow so it can stand out just a little bit. And there's two more properties this text area actually needs. And it needs a size, and that's defined by the width and the height. We can give it 80% of the screen and a height of, say, I don't know, 40%. Maybe our text or our message will span 2 lines. That should be enough for 2 lines of text. Cool. So we have a text area. We have an ID for it, so we can grab it and we can start displaying some messages. So what we need to do is essentially define a message and get and show the message. That's what we're going to do. Commenting is important. Everyone, hope you remember that. So let's say I want to define a message, a string variable. And I just want to say thank you for watching my demo. Really appreciate it. Hopefully nothing breaks and goes wrong. But now that we have our string under this variable MSG, let's get our view. So we need to define another variable. We'll call it text view. I'm going to use this view class, find drawable by ID, just like we did. Well, I didn't do, but Garmin did up here for the time label. And we're going to pass in the ID that we want, which was text, and set this as a text view. Everything looks okay. And then we just take this text view and set the text to be the message that we defined up above. So yeah, cool. Everything looks pretty good. Let's go ahead and run that. Looks like there's no errors. Sweet. We're right on track. Opens up the simulator and it should display our message. Cool. Thank you for watching is shown. That's great. It's a little bit static, or sorry. Yeah, static. It is a little bit static. I don't necessarily like that, and I want to make it look a little more dynamic. So let's close this. And like I mentioned, This on update function is running every second. And so we can actually get access to the seconds property through this clock time variable. And that's exactly what I'm going to do. And let's say we want this message to flash, or maybe look like it's flashing. We can maybe display the message on even numbered seconds and display an empty message on odd numbered seconds. So let's say we have an empty message, which was just an empty string. And now we can use a simple ternary operator on this clock time dot sec property, which will give us the seconds. And we can say, hey, clock time seconds, are you even? And if you are, let's display our message. And if you're odd, let's say, display this empty message. And that's essentially going to display our message on even numbers and display the empty message on odd numbers. So hopefully I did everything right. And we can go ahead and run the application. Simulator opens up like it has every other time. And sweet. Thank you for watching the demo, everyone. Looks like it's working. There's a lot more you can do with this. I encourage you to dive into the documentation. It's really easy to get started. Feel free to reach out to me with any questions. I'm going to continue with the presentation, so don't jump off quite yet, but that's essentially how you customize your watch face in just a few minutes. So moving right along, I just want to close with the future of wearable devices, and I'll start off with the challenges, because there are some. The first one being battery constraints. Well, your wearable device is relatively smaller than, say, your smartphone, your laptop, your computer, of course, and it has a smaller battery. But the demand for these wearable devices is that they have the same functionality, if not more features. So given that there's a smaller battery, but the demand for functionality is quite similar to, say, your laptop or smartphone, there's a challenge there. You have to work with less energy, and you have to somehow work around that. There's some really interesting things that Garmin did with Connect IQ and their SDK and Monkey C that handles this. I encourage you to look into how Garmin smartwatches differ from Apple watches or any other type of smartwatch. It's really, really quite fascinating. Wish I could dive into that today, but don't quite have enough time for that. But the next challenge is ergonomics. Wearable devices are worn for long periods of time, so they need to be comfortable. Also providing value. It's a challenge because a human can only wear so many wearable devices. Well, same with a pigeon too. We can only wear so many devices. And so if you're spending a lot of time developing an application, you just need to decide, is it really worth it? Is it really going to provide value? I can't tell you how many times I've seen wearable devices that are just too hard to use. They just don't seem to be really worth it. I can think of one right now that's supposed to help your posture. I'm not sure if you've heard of these, but it's something you put on your back that vibrates when you start to slouch. And there's some interesting reviews. It just doesn't always stay on. It's hard to put on, and it just doesn't always seem very worth it. I don't want to knock this company, but I think they're doing something really cool. But it's just a challenge that you need to work around. Safety and security is another challenge as we continue to digitize our lives more and more every day. There's a higher demand for security. So for example, digital payments with your smartwatch, you're exposing personal and private information to your devices. And of course, there's a demand that it's secure. And so that's obviously a challenge that needs to be handled. But despite all these challenges, I still think that wearable devices have a potential to continue to change the world, because they have already. And I think they still have a really, really bright future. One industry in particular is the healthcare industry. Us as humans, or people in general, just tend to treat health issues reactively as opposed to preventatively. For example, we don't go to the doctor when we're feeling super great and having an awesome day. We usually go when we're feeling sick and you already have those symptoms. And wearable devices today actually have the capability to track your health and various health metrics. And so we have the potential to essentially forecast for any sorts of health issues and even automatically inform health professionals so they can take the corrective measures to make sure that you don't get sick in the first place. Now, imagine a world where our wearable devices can detect even like neurodegenerative diseases like Alzheimer's and do it in time for us to be able to change course to not even get the disease in the first place. This would be amazing. And there's actually an initiative currently in development today. It's called the Early Detection of Neurodegenerative Diseases, funded by Alzheimer's Research UK, Bill Gates, and the Iceland Foods Charitable Foundation. And this is exactly why I'm super excited about wearable devices. There's lots of really cool things going on, and I hope that they continue to develop and increase our lives, because this just ends up with people living healthier and better lives, which is fantastic. So I just want to say thank you so much for listening to my presentation today. If you have any questions, please feel free to email me or reach me on LinkedIn, GitHub, Instagram, Twitter, and I hope you all have a great day, and thank you so much.